Alright, so I have been asked to make a video tutorial on how trigonometry and the unit circle work. So I will explain basic trigonometry and then I will go on to basically explain what the unit circle is and how it's used. So let me start right here by drawing a triangle, because trigonometry refers to a triangle. I have to say that I am not very familiar with the English terms, well, so I will just use the German ones. Okay, well, imagine I drew that line, so these two are connected. Now we will take some angle. Let's say we take this one and we call it alpha. Now there's a right angle in this triangle, which is that one. So we know two angles, but two angles are not enough to completely define a triangle. But as you should know from school, if we have three components of a triangle and not all of them are angles, we can know everything about the triangle. So if now I know my hypotenuse, which is this side, I will just write h. This is the opposing side, so I will write O, and this is the adjacent side, so I will just write A. So if I know any of these sides, I can determine all the other values in the triangle. That's what trigonometry is all about. Alright, it's not that hard, so let's just dive right into it. Let's define sine, cosine, and tangents. I don't know how it's pronounced. So the sine of alpha would be O, the opposing side, divided by h, the hypotenuse, which is the longest side of the triangle. The cosine of alpha would be defined as A divided by h. So it's the hypotenuse divided by it's the adjacent side divided by the hypotenuse. And the tangents of alpha is defined as the opposing side divided by A, which is the same as the sine of alpha divided by the cosine of alpha. I will write A instead of alpha, and I will add some white spaces so it's easier to see. Alright, to show that that's true, we can just write sine alpha divided by cosine alpha as O divided by h, and that divided by A divided by h. And as you know, you divide by a fraction by multiplying by the inverse, so this is the same as O divided by h times h divided by A. And so we can just remove the h's, and it will be O divided by A, just as a small explanation. Alright, so now that we know this, let's say our angle alpha is 45 degrees. So A equals 45 degrees. Then we know that our sine and the cosine are sine of 45 degrees, which is the same as 1 divided by the square root of 2. You can derive that directly from Pythagoras. Oh god, I'm so bad with pronouncing stuff in English. Anyway, the cosine is the same. So what we know is A and O have the same length because their sine and cosine are the same value. And then we know that tangents of 45 degrees is 1 because A and O are the same. So now we are always depending on knowing what h is. And that's pretty annoying, right? So we can get rid of it with a simple trick. Because what we will do is we normalize stuff. Let's draw a circle. I'd like to make it bigger. Alright, let's assume that's a circle. I guess I'm a bit off, but yeah. Now I will draw a coordinate system here. Okay. Now, this circle is supposed to have a radius of 1. And this circle, ladies and gentlemen, is the unit circle. Now, if we draw any line here from the origin of my coordinate system to this circle, this line has length 1. And what we can do is we take this point right here and we split it up in its x and y coordinates. So let's just do that. How do we do that? Basically, we think of a vertical line here. So let's take this line, all right? Now the length of this line is obviously the opposing edge of our triangle. And because h is 1, the opposing edge divided by 1 is the same as the opposing edge. So we know that of our angle A inside here, I guess I should use another color. Well, the cosine of A is that. So that side is cosine of A. And in the same way, we know that. So good at drawing arrows. This is wrong. Sorry. This is the sine of A, obviously. So sine of A. And this is the cosine of A. So, yeah. The unit circle basically helps you get a normalized length and the components to that. And every point on the unit circle is normalized, which means it has length 1, which is important if you are working with vectors. So if you want to know which direction does my vector point into, or if you want to say, all right, I want to go from point A to point B, let's do that. That's a good exercise and an application for that. So this point is A, and that point is B. And let's say you're making an RTS or something. All right, so we want to go from point A to point B, and let's say for the purpose of this video, A is 0, oh no, let's say A is 20 minus 10, and let's say B is it has to be a bit more on the right, so let's say it's 25 and it's a bit up, so we can say it's 25 minus 8, and because of that we can figure out which or how do we point from here to there. And by doing that we can, or how do we do that? We subtract A from B, and so A minus B equals, well, sorry, it's B minus A. I'm a bit out of it right now. Okay, so this is 5, 2. So we are moving 5 units to 5 units to the right and 2 units up. But with this, how do we like move at the same speed every time? I mean, we don't want to just be there in one frame, right? So what we do is we normalize. We normalize our vector here. Normally you would write a vector differently. You would, a vector would be like this, and then here's 5 and there's 2. But I want you to be able to read what I'm writing, so I'm doing it like this, although some people might scream at me. Okay, so we know it's 5 and 2, and like we have this long vector, but we want to have it at the unit circle so that we have a defined length for it. And we can do that by dividing by the hypotenuse, our x and our y component, because as we know, if our sine is this and our cosine is this in the unit circle, then the x and y components of that, of this, I mean our y component, if our hypotenuse is length 1, is exactly the sine, and if our hypotenuse is length 1, also the x component is exactly our cosine of a. So what we get by normalizing is essentially a representation of the vector, or of the angle rather, that would be like this. So we know the direction, and if we know the direction, we can move at any speed that we want. So what we do is we figure out how long this vector is. And our good old friend Pythagoras, I'm pronouncing him like that, screw this, gave us this great equation, which I will rewrite a bit. So it's basically what it says is h to the power of 2 equals o to the power of 2 plus a to the power of 2, where the a in this equation means the adjacent edge and not the point A here. So I should have chosen better names. But essentially, the hypotenuse of the imaginary triangle here, let me draw the triangle so it's clear what I'm referring to. So think of this rectangular triangle or right angle triangle. So this would have been a bit on the left, but you get the general idea. You think of a triangle here, and then you know, okay, this vector is as long or the square of the length of this vector is the sum of the square of that and that. That's what this equation means. And therefore what we know is that h, I want this in black, h equals, I will make some spaces here so I can draw a square root sign of o squared plus a squared. And now I hope this doesn't look completely horrible, but yeah, that. So like this we figure out the length. So we know that it's the square root of 29 equals h in this example. What? Sorry, like this. Now, if we divide that by the square root of 29, which is a dull value, I should have, let me just change the values so we get a nice result. This stays the same, but for that, let me put a equals 20 minus 10. I can leave that. And b equals, now let's see, 24 minus 7. So we would move 4 units to the right and 3 units up. Then the difference between these two, which is b minus a, so that would be pointing from a to b, would be 4, 3. right? Okay, good. Now, because of that, we get, for h, we get h equals 3 squared plus 4 squared and the square root of that, which is the square root of 25. And as we all know, the square root of 25 equals 5. So the length of this vector would be 5. Now what we do is we divide by 5. So now our normalized b minus a would be 4/5 and 3/5. There you go. And now we know, okay, this is on a unit circle. And let's say I want to move at a speed of a 10th unit per frame. Then I would multiply that. I would just say, okay, I want to, at each frame, I want to add the normalized vector b minus a, so I will just call it nba. Ha! Normalized nba is, again, 4 divided by 5 and 3 divided by 5. And now I will do position plus equals nba times speed. It's as easy as that, because I know the length of nba is 1, because it's a vector that points on the unit circle. Or it's a set of x and y coordinates that are on the unit circle. So the length is 1. And if I now multiply it by the speed, I know that the length of the thing I add to position, whether it can be separate x and y coordinates or a vector or any kind of crazy stuff you do with your position, will be of length 1 times speed. So it will have the length of speed. And if now I add 1/10 of that, I will change my position at 1/10 per frame. So if I can then figure out how long will it take me to go from A to B, because I know the length of the way from A to B is 5. So if I move at a speed of, say, speed equals 1/10 unit per frame or unit per second, you can do all that. I know that the time it will take me is 50 frames, since I'm moving 1 unit in 10 frames and I need to move 5 units, so it's 50 frames. And if I doubled this, I'd end up needing 100 frames and so on, so I can move at a certain speed in a certain direction and end up where I'm meant to go. So for all these, I've seen so much messed up code for moving from A to B in so many program codes. Please just figure out the way from A to B, normalize it by dividing through the length, and then multiply it by your speed and add that to your position. And that way, you can always move at the same speed in the right direction. Yeah, that's it. Thanks for watching.